It's engineering 120, lab 10, circuit 10. This is my lab. This is Matthew Goodenough, section MO1. Circuit. I got my hand tech set up, my potentiometer. Let me connect both of these real quick. So this is the wavelength I get from my graph. My max voltage is I stopped at 2.52, minimum's -0.8, and it's set at 400 hertz. And when I do my calculations for the wavelengths, using those maximum values, I find 2.6, 1.3 volts, and 1.22 volts. Then I get a percent error of right on 5%. And then VOC I found to be 2.47 volts because it is equal to the voltage source. It's equal to this measured value. That's what VOC is equal to. And then when I connect it to the potentiometer, and then when I do it to the potentiometer, you go to DM on your chart.
I needed to remind myself.
And you can measure the voltage, or you can measure the ohms if you connect these.
I wish I still had. I'm displeased to inform you something has happened to our boy Luis.
And then my ohms is about 39.
Hey, bro, shut up. Hey. What happened?
I connected the wrong cord.
We all know.
David.
Elijah should know.
David, I made you to come with me, David.
It's about 39 ohms. That's what I got on that one. And that's my calculated values. And then for the circuit, we make it open circuit, so we disconnect these. If it was connected, we would connect these two wires. We would connect one wire to the hot, which would be this one, and then they'd connect the whole circuit. But to solve it, we solve it by the open circuit method, and we get rid of this potentiometer. We don't need that no more. And that's all we do for that one. And then there's my circuit. Plug that baby back in.
Why do you have to feel this? I don't know. Our manager. Oh yeah.
And then my voltage is about 11.
Did you see this?
The dial moved a little bit, but that's alright. But when I did my circuit, my resistor 1 is 197, 2 is 326, R3 is 500, R4 is 0.915, and my resistor is 39 ohms. Here we do the open circuit method. Our equivalent circuit, that goes to 0, we do no voltage. I solved my VOC to be 5.504 volts. And when you measure VOC, you can measure anywhere in this top node. But the best way to measure it is from where the ground is on this one. So I measured R3 because it goes back straight to ground, so you can get a good voltage, and I found that to be 5.51 volts. So I got like a very small percent error. Then we redo the circuit by equivalence method. We add a voltage source. It's not actually there, but then we solve, those two are in series, or parallel, and then those last two are in series. And you can see my calculations there. Our IQ is 1083. And then my measured resistance from here, I got to be 1080.51. So there's a small percent error there. And then now you solve your equivalent circuit for IL. You use your VTH over RL plus RTH. And I found my IL to be 4.88 milliohms. And to measure the current from IL, you just open your circuit here, measure it, and then I found it to be 4.84 milliamps. And that concludes my lab. Thank you for listening. This is Matthew Goodenough, Engineering 120, Lab 10, and that was my lab circuit and my completed values and calculations from here. Thank you, bye.